Hello everyone and welcome to our panel, Interdisciplinarity in Digital Scholarship. I believe that both of these topics that we will be talking about today, interdisciplinarity on the one hand and digital scholarship on the other, and the intersection between them will be highly important for the entire conference of future education. We will have 4 presentations today. We will try to keep each of them up to 10 minutes. And I propose that we first go with all the presentations and then take questions at the end. So if you have a question during someone's talk and presentation, please write down those questions, and then at the end we will hopefully have about 10 or 15 minutes for all those questions and the discussion. So our first presenters will be colleagues from the Ethnographic Museum in Belgrade. Bojan, Đokić, and Ivan Maksimović will be talking about future perspectives in connecting sciences and humanities. Please.
Thank you. First of all, I would like to apologize for the short minute changes. Ms. Čolak-Antić Popović was kind enough to trust in us to give this presentation, and Ms. Novaković was unable to give the talk, so I will be instead of her. And we will try to give a brief overview of the efforts that we made at the Ethnographic Museum in Belgrade to establish interdisciplinary educational activities and perspectives of utilizing digital media to enhance their potential. So I would like to thank also the organizers for the opportunity for us to present this modest contribution. Now, firstly, I would like to give a brief introduction regarding the Ethnographic Museum in Belgrade. It was founded in 1901, as you can see, and it has now more than 50,000 artifacts, and most of which are related to Serbian culture, especially traditional Serbian culture, because the mission of the museum from the onset was to collect these artifacts and to collect the knowledge regarding the traditional culture, which was slowly disappearing even at that time. So this was the mission that was for a very long, for the most part of the museum's history, its core mission. Now, since 2003, we offer a program called Child in Tradition, which operates within the museum, and as a project, it covers workshops and other programs directed towards children in order to foster knowledge of and interest towards cultural heritage. The project has striven towards interdisciplinarity since its inception, and this is evident in at least 2 ways, as you can see here. So firstly, we cooperate with professionals from other fields in order to enhance the main goal and the core message of the project, which is to educate and stimulate interest in cultural heritage. The second form of interdisciplinarity that we also foster is connecting ethnology with other disciplines to make learning more fun, efficient, and creative, as well as to contribute to a more complex and holistic understanding of the world and its phenomena. Now, a good example of this first form of interdisciplinarity is the play, A Christmas Dream, a photo of which you can see here, which was staged in the early 2000s. Now, the story revolves around a pair of contemporary children who get magically transported on Christmas Eve into the past of their grandparents, who show them how they celebrated this holiday. And the play mobilized the help of theater professionals, stage director, playwright, composers, set and costume designers, and even professional actors. All of this was in order to ensure that the idea behind the play is clearly communicated. So it was important for us to associate with someone who knows the medium of the stage play in order to make our message more clear. Now, moreover, all of our programs are developed with the help of child education experts who ensure that all the programs, including workshops, closely follows school curricula. Now, however, we would today like to primarily talk about the other form of interdisciplinarity, which is represented in the form of two workshops carried out at the Ethnographic Museum since 2015. The one is called By Grain Per Grain, and the other is Visible and Invisible About the Egg. These two workshops were conducted in association with colleagues from the Faculty of Chemistry, University of Belgrade, including, and most instrumentally, Mr. Bojan Đokić, who will now take the floor and tell us something more about these workshops in detail.
Thank you, Ivan. Good afternoon, everyone. And my part here is to talk about our two workshops. And first of that workshops is, as Ivan said, By Grain Per Grain. And what was the cause of this workshop? The first part of this workshop was learning about customs related with our ritual breads, and is performed by curators of Ethnographic Museum in Belgrade. And the second part is chemistry part, where the kids have opportunity to do examination of main ingredients of dough and to get to know bread making process more clearly. And as you can see, these are some pictures from that workshop, that first workshop. Our second workshop that we're doing together is Visible and Invisible About the Egg, and it's about our tradition, our Easter tradition. And first part, and that's ethnological part of this workshop, is about painting the eggs in a traditional way. And the second part, or the chemical part of this workshop, is examination of eggshell properties and egg contents. On this workshop, students age 9 to 11 have first opportunity to do science experiments and to get to know more about lab equipment that we use, such as test tubes, Erlenmeyer flask, or beakers, and they're all doing that simple experiment with our instructions. And these are photos that represent first part or ethnological part of this workshop, and on the second part we can see students that work on laboratory equipment. We represent our worksheet that's prepared for all students. And on the first page, on this page, we prepared a cultural heritage page, and you can see here questions and proverbs that we have in our Serbian traditions, and also a legend and stories about the egg. And second part is about, thank you. And second part is about experiments that children do on our workshops. How does it work? Students work in groups of 5 or 6 students are in one group, and these workshops are managed by curators and students of chemistry, and questions that we are asking them and that are connected with experimental work are: when the flour turns blue, what is the bait for yeast, what compound is formed when yeast is active, or is there water in egg? And when they do all our experiments, they get to know the answers on all these questions. The research involved 240 third grade students and from 7 primary schools and 7 primary schools teachers, and students and teachers emphasize these following statements. The concept of workshop is interesting because students search for answers while doing experimental work. That's the first part. And second, the students are encouraged to make different assumptions and to communicate all pros and cons during the work of experiments. So now I will give the word to my colleague Ivan to tell something about educational game of Ethnographic Museum.
So in order to fulfill this potential of interdisciplinarity, we started developing the idea of a web game for children, which would be hosted on the museum webpage. And the title of the game is Walk Through the Ethnographic Museum, Life in Serbia 150 Years Ago. So it is, well, the concept behind it is life in the past in Serbia, and children are invited to explore the museum in order to learn more about its activities, but also to discover something more about the past, and to deepen their horizons of knowledge. Now, we believe that digital media offers two possibilities that are simply not available elsewhere, and that can help us really to fulfill these potentials. Now, firstly, it enables a potentially endless space for material which is related to this interdisciplinarity, and material that comes from different areas of knowledge. Now, also the potentials for connectivity are endless, so we can in that way broaden the scope of any topic. And this is perfect for interdisciplinary approaches because we can easily link materials and topics that are of different disciplines, link them together and present them in one place. For instance, we can enrich the story of food culture in Serbia in the past with examples and experiments in food chemistry. Now, it is not difficult to imagine other potentials that can also include other disciplines, whether they come from natural sciences or social sciences as well. Now, secondly, visual interface, the animations, the effects, and so on, are also potentially limitless. And just like the play that we discussed earlier, it is able to enchant and involve players in the setting and make them enter the world of the museum in a way that was maybe difficult to understand if they were just simply visitors. So in this way, it will sensitize them and prepare them for the visits, for an actual visit to the museum and a face-to-face interaction with material objects by transporting them into this world of past and by engaging with their imagination.
I really apologize for interrupting this very interesting presentation, but we are 2 minutes over time, so if you could just please wrap it up.
Thank you. I was actually reaching the end. So thank you very much for the attention and the opportunity to present this.
Okay, that was it. Sorry then. Thank you again. And so our next speaker is Andreas Riepl, who is the head of the Federal Center of eEducation in Austria, Vienna, and he will be talking about eEducation strategies and impact of Austria's digital agenda. Thank you.
Thank you. Yes, my name is Andreas Riepl, and I'm head of a network consisting of 2,600 schools in Austria at the moment. We have a total of 6,000 schools, so we're going towards half of all schools. And it's a project that is not only horizontal but also vertical, which means that we start at primary level and going all the way up to upper secondary level of all schools. And the main title of our project is to get schools digital on any aspect you can think of, starting with digital competences of teachers and going all the way to the development of the organizations by looking at school management aspects and trying to get schools involved. But the main title of this initiative is how to develop teachers' digital competencies. So actually we have quite a large budget, which is just in place for teachers to do further education on the digital agenda. Just to relate back to the person that I am I'm also entrepreneur, so I have a company with 10 software developers, And I know how hard it is to find new workforce that is specialized and open to flexibility and changes. And the most important part, I'm still a teacher. I teach at a pedagogical university college. I work with students there, but also I teach at a business school. And this is, for me, always a good connection to the reality. And I think this is also an important part in our network work where we succeeded in involving different communities that had formed in the past 10 to 15 years, and it's not a nice word to say, but assimilated them into one big network. And the numbers that you see is that schools that enter this network, they start with a so-called member status. That's nothing more than filling in a web form, but then they can excel and develop and have sort of expert status of a certain time. And we have 1,700 member schools in the system at the moment, 800 that have documented their agenda and on the digital aspects, and 105 which are so-called Expert Plus, which are the ones that have established using digital media and everything throughout the whole school for a long period of time. Involved school types are starting at primary level, and what we do is we don't emphasize on using digital aspects at primary level, but we emphasize on logical structures, on coding, on problem-solving capabilities. And when we hear that about the crisis of universities, I stress that this starts a lot earlier. And what we have to take a good look at is on how we can help teachers change their way of teaching, so that will be positive for the students. And so in the primary schools, we try to focus on how to develop those problem-solving skills. And then starting with secondary level, we focus on using a digital aspect and for also to use them in a very responsible way. For example, we have one initiative called Safer Internet that does nothing else but shows about sort of the dangers of aspects of social media and so on, but also tries to promote the positive sides of using technology. What do our schools work with? They have different aspects that they concentrate on, and if you see, the bottom line is using digital media in classroom work, but also school development. And this is very important because this is an issue. If the whole organization goes towards this direction, then it is likely that all colleagues working in the school will also adapt that. We are in a big OER initiative. We heard that 2 days back, that open educational resources are very important. Also, our main focus on open source as well. And the teachers produce content that they get paid once and then share with others based upon Creative Commons licensing. And this is very widely used. We have something implemented. It's another tool that it's called DigiCheck, which does the following. It allows teachers to check in an anonymous way their digital competences. And there's a self-reflection part and a sort of testing part, and that matches, and then that's part of the reality. And then there are different programs that teachers can try to develop in form of further education if there is lack in one certain digital area. And this testing is also done at secondary level for students. We have something like big data, which means that we have aggregated statistics. The big focus and advantage of Austria is that we're so small that we have one centralized strategy. It's a different situation, for example, in Germany, where they have 16 educational systems. So we can really focus, and it shows that it has impact. We have developed a quality matrix, another tool for schools to identify the position where they're in and how development is possible. We focus a lot on the self-reflection aspect and have tools that even help schools to develop a digital concept for this aspect. One big issue is that we have, of course, schools, they need consulting, and so we have a network of 70 persons throughout Austria Austria regionally and also throughout the school levels that support these schools. And what you see here is a list of around 40 activities that schools can document what they do digitally. And this is then reflected with this network of 70 people. And if they acknowledge one of these activities, then they gain points. Schools gain points. And depending on class sizes and size of the school, they then at a certain time have enough points to gain or to have this expert status. And from this moment on, they access our budgets for further education and projects on the digital behalf. And so this is a sort of a gamification concept that has been integrated, which works quite well. We have a statistic dashboard for our 70 coordinators that show how the schools are on their way and how to help them in a positive way. We have a consultants database, which means that we have different technologies and people stand for different technologies, and schools decide which basic technology they want to work with, and then they have the consultants that help them out. Of course, we also refer to the models that you probably all know, which try to emphasize on how to use digital agenda in classroom, starting from having to know the technical part to be able to judge when it is it makes sense to have technology in place for learning processes, as well as the Dagstuhl model that also reflects towards the social-cultural effects, and the Summer model, which identifies on how to use technology in digitalized didactic courses. One of the main fields of focus at the moment is the school management, because schools work differently than companies, and we're actually communities of practice and experts relate to their subject and not to their organization. And this is a big challenge for the school management itself, but we're trying to help them and identify the problems and help them by showing them that clear goals are needed and that the development, the digital development of colleagues and trying to be a team are essential aspects, which means that school management should always be a form of a role model, have aspects of participation, integrate new technologies, have a shared vision, and put the we into the foreground. We've done piloting with all different technologies and have shown that there are entry points available for everyone. But actually, it's never about the technology itself, but how to use it. And if you just take a look at the learning process, it's input, the student processes, there's output, there might be an iteration, and at the end, there is a grade, there is a reflection of the situation. And if you take the teacher's perspective, it's trying to fulfill the curriculum on one side, individualization aspects, but also addressing future competencies. And sorry, this does not look quite right, but just to give you the impression, Google and Microsoft, they have tried to focus and research what are the competencies that are needed for future employees for their companies. And even Google has revised these different aspects for future. And my question, my provocative question is here relating to universities. If the students that you work with address these different competencies, because that's what we try to emphasize on during schoolwork. And this is something totally different than what we have done. The problem that we have at the moment is that we have 120,000 teachers in Austria, and this might relate to about 10,000. And the question is how to address the rest. The conclusion is on this page. Artificial intelligence is getting better, so we have to find ways on how to work with that on a humanistic way aside. We have no monopoly on knowledge anymore, and so we have to see technology as an enabler, find new didactics, and collaborate. That's the most important part. And these are all sets of 21st century skills that relate to the school system as well as the university system. And so actually it's not about technology, but the change, pedagogy, and future skills. and focus on the interdisciplinary. We're trying to do this. Thank you.
Thank you, Andreas. Our next speaker is Milena Stanković. She's a professor at the Faculty of Electronic Engineering, University of Niš in Serbia. And Milena will be talking about educational challenges related to data sciences across disciplines.
Okay, since I'm coming from technical field, I would like to speak about data science engineers or data mining engineers, which is one of most promising profession today, because data science is one of the main part of artificial intelligence. And also, this area is a nice example where we need multidisciplinarity in education at high level. Okay, main topic in my presentation will be data. Data which are everywhere around us. Today we are all connected to the internet, and we are communicate by using mobile devices and mobile phones. People, businesses, and devices have all become data factories that are pumping out incredible amount of information to the web each day. Now we are living in the world which is different, not comparing with 100 years ago, not comparing with 50 years ago, but comparing with 10 years ago or 5 years ago. We are living in a world when we have exponential growing of information which are available, and also of exponential changes in the life. For example, 90% of all information at the internet has been created since 2016, 19%. That means exponential growing of information. According to the prediction of International Data Corporation, next year the total data on the internet will be 45 zettabytes. Zettabytes is huge number. This is a number with 21 zero outside one. That's incredible. Today, this big data on the internet, for this beta on the internet is guilty. It's possible to say Internet of Things. What means Internet of Things? The term generally refers to the scenario where network connectivity and computing capability extend to objects, sensors, and everyday items which are not considered as computer. That are ordinary engines, devices, sensors, and so on. Those devices generate, exchange, and consume data with minimal human intervention. They communicate between them. This big quantity of data is only one side of the problem that we have. The other side of the problem is the quality of the data. Traditionally, we have programs, we have algorithms to work with structured data, data which are well prepared for processing. For example, this kind of data are data in databases, SQL databases, transactional data, or matrices and trees in scientific application. However, on the internet today, we have a lot of unstructured data which are not prepared for processing. Those data are prepared for human consumption. For example, this kind of data are different text from emails, from blogs, from comments, and so on. Then images, audio and video files, also different kind of machine data. For example, each application has log files, like web log files, application log files, and also there is a lot of data nowadays from mobile phones. Those kind of data are not prepared for processing. And then we have situation when we have big data, a lot of data, and a lot of bad quality data for processing. And from other side, we need new technique, new methodologies, new algorithm for processing this kind of data to extract some information which are inside of those data. There is a lot of available information in those data, and we need tools, algorithm to extract information from those data. One of the ways to solve this problem is data science or data mining. And here I will mention machine learning as one of technique used in data science. Machine learning today is used in two different forms. One is supervised machine learning, and the other is unsupervised machine learning. In case of supervised machine learning, we have a set of raw data, big collection of data, and also we have a set of labels relating to the classes of those data. This information about label usually is done by supervisor, by human beings, and by using part of data prepared for this processing and those labels, we are creating the model of the engine which will generate corresponding classes of the data. One part of the input data is used for verification, and when the model is verified, then we have tool which is possible to use in real time for classification of this kind of data according to their properties. For example, this concept today is used in the big project for autonomous car. They are using data from the past to define the engine which will drive the car autonomously. The second machine learning technique is unsupervised learning, which is usually used for clustering. Here, there is no information about classes of the data, but we are using some function on similarity or some definition of distance between objects, and by using of those definitions, we are classifying the data. This concept is convenient for use in real time. There is a lot of area where data science is used, for example, in medicine, medical image processing, genomic and genetic creation of drug, in business for defining strategies, but prediction of time series, and so on. For example, in economy, in business, today are very popular recommendation system where the data from the past are used to predict how the customer will react in the future for some product. One new area in this domain is industrial data science, and this concept today is used for quality control, anomaly detection, cost reduction, and this concept today is basis of the concept of the fourth industrial revolution. First was related to steam power, the second to electrical engine, the next to automatization and computer, and next is not only application of new technology, it is a concept of changing of the business model. New factory, they are not producing only the good, they are providing services, customized services related to those goods. For example, services to control the quality of the machine. Okay, for the end, few words about education of data engineer. Data engineer need to be educated in different fields. One big part is mathematics, is statistics, machine learning, classification, clustering, time series prediction, dimensionality reduction, theory of optimization, and so on. The second part is software engineering, programming languages, tools for work with, for parallel computing, for work with big data, and so on. But that is not enough. For presentation of the result, because they are not explicit, they are implicit, they need to be good presenter. They need to use tool for visualization, for analysis. From one side, they need to be new kind of arts. Also, to understand different problem in different area, they need to have a good communication skills. They have to be good in analyzing problem and finding good solution for solving those problems. Unfortunately, our education is not well prepared for this kind of engineer to teach this kind of engineers. We have, for example, here in Serbia, we have good mathematicians from one side. From other side, we have good software engineers, but we need connection of those two professions with communication skills, with skills for visualization and presentation, and because of that, we have to change our education system. Needed education system have to be open and flexible, and generally, it's possible to say this education system have to prepare young generation for exponential growing of technology and exponential changing in the life. That's all.
Thank you.
Thank you.
Thank you, Milena. And I will be the last speaker for today, and as Milena was talking about the future of education, educating data engineers, I will actually be talking about some efforts to educate scholars in the humanities and social sciences. And in talking about that, I actually like to start with this quote which says, I went to sleep one day a cultural critic and woke the next metamorphosed into a data processor. I think that this quote captures the feelings of many scholars in the humanities and social sciences who perceive that transition toward digital scholarship and interdisciplinarity that it brings as a sudden and profound transformation that influences the very core of their professional identities, practices, and expertise. Now, my work over the past several years and still ongoing has explored this transition of the humanities and social sciences towards digital scholarship and increasing interdisciplinarity. What I would like to do here is to share some of the results that summarize findings of several studies I conducted at 23 educational research and funding institutions in the United States and in Europe, and which involved more than 250 participants. This research included both theoretical and action-oriented work, as I will elaborate throughout the presentation. And the question that I want to focus on here is how can we build interdisciplinary digital research capacity in the humanities and social sciences? In particular, I will focus on two aspects of capacity building relevant for digital scholarship and also for this conference. The first of those those aspects is knowledge capacity. Because the precondition for benefiting from digital research tools and methods is mastering those resources in a systematic, learned manner. Yet, when I ask my respondents, scholars in the humanities and social sciences, where do they learn how to use the digital research methods and tools? The undivided response is, can you guess? Nowhere, exactly, on my own. So, as we see in this quote, one of the associate professor of linguistics with whom I spoke says, I ask around, it's just like word of mouth. I sort of bump into it, or a colleague will shoot me an email. It's not organized and strategic at all. So scholars in the humanities and social sciences are often aware of methodological and epistemological benefits of digital research tools and methods, but they're not in a position to acquire relevant skills and knowledge. As one of the respondents put it, I haven't used technology in my research in a pervasive way to really think about epistemological issues. I'm not opposed to using technology to analyze, but I haven't had a chance to learn it. An important reason for researchers' inability to develop digital research skills is a structure of disciplinary incentives and rewards. My respondent explains, for instance, that when a training session on digital research tools and methods is organized at their university, hardly any of the faculty, especially tenure-track faculty, attend. And this is the first impediment to developing knowledge competency, which is the structure of the incentives and rewards. As this assistant professor of art history says, we are not rewarding for doing that, for actually developing competencies and learning how to use digital research tools and methods. What we are rewarded for is publishing, and going to one of those sessions where they would learn about digital methods takes away time from our publishing. So there is a lot of resistance. Another important impediment is that currently prevailing organizational strategy places digital scholarships in libraries and other spaces outside the central disciplinary workflows. Such educational initiatives often lack clear strategy and focus on technical features and skills rather than on field-specific research questions and needs. Instead, what we need is humanists and social sciences favor and really best learning practice when instruction is closely integrated to their area of study and when it unfolds organically through collaboration with colleagues. This was the approach of our work in the Alpha Lab or Humanities Lab project at the Royal Netherlands Academy of Arts and Sciences in Amsterdam, which focused on integrated humanities and social science knowledge, experience, data, and tools. Our aim was to develop a network and a set of prototype tools for research in the humanities and social sciences. I was part of the Interface Lab research group, which, as the name suggests, served as the interface between different areas of expertise, knowledge, and data, making sure that the tools are developed through successful interdisciplinary collaboration. Now, digital research tools we developed included tools for text analysis, historical GIS, and historical population counts. In addition to developing tools, one of our main goals was to develop a safe space where our scholars across disciplines could freely ask, experiment, make mistakes, get frustrated in our interdisciplinary work. We discussed various challenges encountered in interdisciplinary practice and facilitated scholars' sensibility to new ways of working and approaching objects of inquiry. Here is what one of our Alpha Labs colleagues said about her experience in that regard, and I hope that this sound will work. If not, we will just skip over this slide.
In the collaboration with the software developers, each time when they showed me their newly developed functionalities, they made me see new possibilities to ask new questions to the material, and I got back to them and asked them even to build even more functionalities, because I didn't see the possibilities before, but only during the process of developing this digital tool.
Now, we also assisted scholars to articulate their discipline-specific methods and research objects, as well as to develop the common vocabulary, which was needed but not always easy to reach. Here is what another of our colleagues, this time from the IT department, said about that. Oops.
Sometimes you talk about a topic and you have a completely different notion than the other person has. For example, one time I was talking with social scientists about questions and variables that they measure, and we had a long discussion, and it appeared that they have a completely different notion on variables than I, from an ICT background, have. And you can always have a laugh about such mistakes. You will always be forgiven, luckily. So that's quite interesting for me.
So that was an example of one of those safe spaces that I mentioned that we were trying to create. And I will try to go briefly. I'm aware that I'm probably running out of time, seriously. So in addition, and closely related to building knowledge capacity, is the second important area of capacity building I want to talk about, which is technical capacity. And building technical capacity is important because digital scholarship is not just supported by technology, but actually constituted through it, because research tools shape both the object of inquiry and the ways of knowing it. Therefore, scholars' involvement in digital research tool development is a profound question concerning the kinds of research practices and ways of knowing the digital tools enable and promote. It is not the question about the configuration of technology that shapes both what we know and what we can know. However, when it comes to influence that scholars in the humanities and social sciences have on the tool development, the results are pretty similar with both commercial and academically developed tools, minimal to no influence. As this professor of history says, we seem to have no influence at all because no one talks to us or asks us or listens to us. A common comment coming from the IT side is that scholars in the humanities and social sciences either do not know what they want in a tool, or they don't have the vocabulary and frame of reference to explain what they want. So this is where the issue of knowledge capacity arises again as crucially important. Scholars in the humanities and social sciences need to build knowledge capacity that would enable them to influence the development of digital research tools and resources. As this scholar put it, unless humanists and social sciences take seriously the value of their own contributions and perspectives on the nature of knowledge, digital tools and resources will be built without those values. It is not why the humanities and social sciences matter, but how do they matter that we need to put forward. And taking seriously those values of humanities and social sciences contribution on the development of digital research tools and resources was the focus of the second action-oriented work that I wanted to mention here. That was the Power of Words in Traditional European Cultures project, which connected teams in 9 countries. And we focused on digitizing words of power. Words of power are curses, blessings, and so on. So now, our work centered on thinking through how those various sources to be digitized would be used in research, what kind of questions would be generated. So we wanted to do more than simply digitize in the usual sense of the term. Our goal was to build a digital resource shaped by research practices reflecting humanist and social sciences ways of working that closely link data with interpretation. We wanted the values of the humanities and social sciences to be built and reflected in this digital resource. So in conclusion, theoretical and action-oriented work focused on knowledge and technical capacity building is vital for the overall value building and supporting transition of the humanities and social sciences towards digital scholarship and increasing interdisciplinarity. And I thank you very much for your attention, and I welcome any questions that you might have for all 4 presentations. Thank you.